It is always in motion, captivating in its flow, its ever-changing form, and in its sound. On a never-ending journey between the sky and the earth, our water is never the same. "3,000 meters above the ground, the furthest away from where water can possibly flow, we look at the ice, the snow, and the lakes as being pure and pristine, as untouched, with no human trace in sight. But scientists come all the way up here with a different view, because they know about toxic chemicals that can travel thousands of miles, settling down in cold places all over the world, contaminating sources of our fresh water. Toxic chemicals that are hard to trace on the ground and in the atmosphere. Scientists come all the way up here with simple tools, but the answers they're trying to find are far from easy to deal with. They come here to look for POPs, Persistent Organic Pollutants.
Persistent organic pollutants are significant today because of their persistence and because they have been accumulating in different areas. For example, in ice fields, which are now starting to melt. And what we've seen in the recent studies is that this release of fresh water, for example, from glaciers, is introducing again these a significant amount of persistent organic pollutants in the environment. Even at low concentrations, they might have effect on the long term.
POPs belong to the family of synthetic chemicals currently or once used in manufactural, in agricultural, or industrial processes around the world. POPs are persistent in nature. They can resist environmental degradation through physical and chemical processes, staying in the environment for hundreds, sometimes even thousands of years. POPs accumulate in living organisms. They don't like to dissolve in water, but they do like to accumulate in the fatty tissue of the organisms, putting them at risk of chronic poisoning. And POPs pass from one species of the food chain to the next, exposing organisms higher up the food chain to higher levels of toxicity. Eventually, it is through the food we eat, the water we drink, or even through the air we breathe, that persistent organic pollutants can enter our body. Even at low doses, POPs have been linked to cancer, damage of the immune system, endocrine disorders, Parkinson's disease, or diabetes. 3,000 meters above the ground, scientists collect snow samples for laboratory analysis. Are there POPs in the snowpack at all? If so, in what concentration? How healthy are the headwaters in this region? Digging a snowpack of 1 meter depth is the crucial first step to find out, because POPs hide in different kinds of snow, from different time periods of the year in different layers, with different densities. Only a carefully collected sample from a snow profile is useful to the scientists.
We need to make sure that it's all smooth, the whole profile, and there's no contamination from upper layers to lower layers. Since we were digging, it's always possible that snow from the edges fell into and got stuck to the upper layers or to the layers below. So it's just cleaning a little bit up the whole profile. Now we've dig the hole until the ice, so we cleaning it up a little bit, and then we can start to do the measurements.
Once the density of each layer of snow or ice has been weighed and their water equivalent has been calculated, scientists know how much snow they will have to collect to be able to detect the toxic compounds in the snowpack.
Okay.
Sometimes they have to be ready to carry at least 10 litres of snow all the way down the mountain and back to the laboratory for analysis. But why do we find POPs in high-altitude mountain regions, such as the European Alps, in the first place? How do persistent organic pollutants get to such remote areas of the world, so far away from human activity? POPs are atmospheric contaminants. They can disperse into the atmosphere, and they can spread all over the world by atmospheric currents. POPs are semi-volatile. They can easily evaporate in warm regions of the world and condense and accumulate in cold regions of the world. For example, in Arctic regions, or in high-altitude mountain areas such as the Himalayas, the Rocky Mountains, or the European Alps. This is where they are deposited and retained, and as the snow and the ice in these areas melts, persistent organic pollutants will find their way into our headwaters. POPs are hard to discover, and they are hard to cope with. Scientists will keep having to monitor cold areas around the globe. Their job will never be done.
Monitoring the persistent organic pollutants, it's very important. It's not the same sampling only once in one spot than sampling more times, different circumstances, for example, different seasons, different years, to see how is the trend. So where will they end up? How will be the concentrations in 2015, 2020?
Even in some of the world's most remote places, our waters are not safe from human impact.